So
Yes.
the first thing in these problems, okay, in combinatorics, pretty much any problem in physics or math or whatever, it's always useful to draw a diagram of some kind. Doesn't matter. Just like something to visualize it. Because if it's in your head and it's abstract, which is what this is, it's gonna be a little bit difficult to just like get the answer from your head. What I mean is, here's how I would start. I would say, okay, so Peter needs to decide the order in which to schedule 14 exams for his school. So there are 14 exams. Cool. 2 of these are Chem, SL, and HL. All right. So this is what I would do. I would say, well, let's say I have a schedule. Okay. Schedule. This is a schedule.
Yep.
This is a schedule. Oops. And how many open spaces should I have? Well, there's 14 exams, so I'm going to make 14. So I'm going to say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. It doesn't look like the previous. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Great. So I would draw this. I would say, okay, well, I have 14 open spaces, and I have 14 objects, 14 balls, or 14 exams to put these in. All right, so far so good. Now, can I directly find, like, all the different ways in which I can schedule the 14 exams, given that the 2 chemistry subjects are not consecutive? Like, can I do this directly?
Can you do it directly? Well, we have to use permutations here.
Sure, but I mean, like, is there a direct permutation, maybe a multiplication of permutations that I can do that it was going to give me this? Or let me rephrase the question. So find the number of different ways Peter can schedule 14 exams, given that the 2 chemistry subjects must not be consecutive. Okay, so let's say I'll just answer the question. No, you can't. There's no simple way of just saying, okay, well, it's going to be this times this times this. There's no such formula. I mean, there can be, but it's too complicated for what we're actually trying to do. It's like it wouldn't make sense to attempt this. So a better thing would be to do like you did and say, okay, well, let's take all the different ways I can put them, and I'll just subtract all the ways in which they are consecutive, which is the correct logic. But now, how do you find the expression? Okay, so let's do this. So how many ways can I put these in? 14 permute 14. Or, equivalently, is the same thing as saying 14 factorial. Right? Because I have 14 ways, I have 13 ways, I have 12 ways, 11, 10, 9, 8, da, 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 da. That's really how, like, so let's say I have 6 objects that I can put. I would have 6 factorial ways of ordering those objects.
Yep.
So you could even bypass the permute like notation and just say like 14 factorial. Okay, good. This is fine. So let's say they are together, right? So what we would say is that the total number of ways, so total number of ways minus number of ways number of ways together, right? Let's just say that. I don't know how to write it more neatly than this. So okay, all right. So now how many ways can they be together? So let's say I put them together. I have either Chem SL, either the SL is going to be first, right? Or it's going to be second, right? It's either it's here or it's here. So how many ways, how many ways can I order the little box SOHL? Well, there's 2 factorial ways. It's either HLSL or it's SOHL. Okay, super. So I'm going to say there's 2 factorial ways of ordering the box of them being together. Okay. Now, let's say we keep them in this box together and assume that's like one thing. And we have 12 other exams that we need to schedule. So really we have 12 exams we need to schedule plus one box of exams. So I have 13 objects. How many ways can I order those objects?
Well, that would be 13 permute. 13, so 13 factorial.
Exactly. So there's 13 factorial ways of ordering the 12 exams plus the combination of those two exams that I've put them together. I've said, okay, this is one thing because I'm always going to move them together, right? Because they're together. And so really, there's 2 factorial ways times so there's 2 factorial ways of arranging those 2 exams, and then 13 factorial ways of putting them. Either those 2 exams can be here. That's one. I mean, let's just check to verify if this makes sense. So there's 1 way, there's 2 ways, there's 3 ways, 4, and say 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Right? I'm just shifting by 1 every time, right? But the idea, it's essentially like the same thing as 1 exam, except it has a length longer. So you end at 13 instead of 14. You can think of it this way too. Okay, so it makes sense.
Okay.
So really what you have is 14 factorial minus 2 times 13 factorial ways of doing these. And this would be your answer.
But why do we have to use the 2 factorial? Because I don't think the order matters, whether it's the HL test first or the SL test first.
Okay.
As long as they're next to each other.
Let's test that logic. Because what you're saying, right? Okay, so let's see. Peter needs to decide the order in which to schedule 14 exams for school. 2 of these exams are chemistry, 1 SL, 1 HL. Find the number of different ways Peter can schedule the 14 exams, given that the 2 chemistry subjects must not be consecutive. You see how this different means that order matters?
Different. Oh, okay. So SL and HL would matter.
Yeah,
order would matter. Okay.
Thinking of it another way, if order didn't matter at all, then we would just have 1 combination in general, like for all 14 exams, because it wouldn't matter which one's first. And the moment you start ordering, whether it's chemistry, HL, or SL is in front, then all of a sudden everything matters.